Lesson 6.2, Bisectors of Triangles. All right, first of all, we're going to need to identify the word concurrent. Concurrent is when several lines intersect at the same point, and that point is called the point of concurrency. So the lines are concurrent if they meet at the same point. The point is the point of concurrency. The concurrency of the perpendicular bisectors of a triangle theorem says that the perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices of the triangle. Because remember, the perpendicular bisector theorem said that any point on a perpendicular bisector is equidistant from the sides, from the ends of the segment. So if we have a big triangle, any point on a perpendicular bisector would be equidistant from the ends of that segment, which would be the vertices of the triangle. So there's a triangle, there's a perpendicular bisector. There's another perpendicular bisector. There's another perpendicular bisector. This theorem is saying that that point right there is the same distance to all three vertices. Let's try an example. Hot pretzels are sold at stores A, B, and E. Where could the pretzel distributor be located if it is equidistant from those 3 points? Well, we could start by drawing a triangle, because if we want a point that is equidistant from the 3 vertices of a triangle, it's where the perpendicular bisectors are. So then draw the perpendicular bisectors. Draw another perpendicular bisector. Another perpendicular bisector, so it's about right there. That is going to be the same distance to all 3 points of the triangle. Or a much nicer drawing. I did really bad at guessing my perpendicular bisectors, apparently. Get another term called the circumcenter, which is the point of concurrency of the perpendicular bisectors of a triangle is called the circumcenter. So the place where the 3 perpendicular bisectors of the triangle meet is the circumcenter. The reason why we call that, because if a circle was circumscribed around the triangle or drawn around the outside of a triangle, the circumcenter would be the center of the circle. Why is that? Well, here's a triangle and a perpendicular bisector and another perpendicular bisector and another perpendicular bisector. So remember, that point is the same distance to each vertex of the triangle. If I draw the circle that goes through the 3 vertices, that's a circumscribed triangle. Notice all 3 of those lines that I drew, all those 3 of those segments I drew, are radiuses. They're all the same length, all go to the same point. So that would be the center of the circle, and the distances to the vertices of the triangle would be the radiuses. The angle bisectors of a triangle are also concurrent. They meet at a point that is equidistant from the sides of the triangle. Because remember, if we had an angle bisector, it was equidistant to the sides of the angle. So for the triangle, it will be equidistant to the sides of the triangle. We call that point the end center. The point of concurrency of an angle bisectors of a triangle is the end center, because if a circle was inscribed or drawn inside the triangle, it would be the center. So there's a triangle, there's one angle bisector, another angle bisector, and a third angle bisector. The theorem is saying that that point is the same distance to the sides of the triangle. If we were to inscribe a circle, those would all be radiuses of the circle. So it's called the incenter, because it's the center of the circle inside the triangle. So let's try an example. In this example, N is the incenter. We are supposed to find the length EN. I don't see how to find EN, but if I look, I know that line segment and this segment, and it makes a triangle with FN. And since it's perpendicular, it makes it a right triangle. If it's a right triangle, that means I can use the Pythagorean Theorem, which is a squared plus b squared equals c squared. In this case, my A is segment FN, the B is 16, and the C is 20. Okay. Let's use our calculator. 16 squared is 256. 20 squared is 400. Subtract the 256. So FN squared is 144. And then we'll have to square root. So if I square root that, FN is 12. How does that help us find EN? Well, if N is the incenter, then EN, DN, and FN are all the same length, because the incenter is equidistant to the sides of the triangle. Therefore, EN is the same as FN, which is 12. Would you pause this and try number 6 and 12?